question and answer on mechanics, which have a title XTP111 or BPH 111, Introduction to what? Mechanics, heat energy, heat and the properties of matter. So what we are dealing with is for a course which we'll call PPH and what? Mechanics. So if you have not subscribed to this channel, endeavor to subscribe. Then if you have subscribed, just like and share to your friends. Then if you have subscribed, like and share to your friends. If you have not subscribed, subscribe and what? Turn on your notification bell for more video. Let's go to the question. Question number 1. The period of vibration T of a liquid dropped is given by T equals to K R raised to the power X, density raised to the power what? Y, and Y raised to the power Z, where K is a constant. That's what they told us. And R is the radius of the drop. Q is the density of the liquid. And Y is the surface tension of the dimension, surface tension of dimension mt squared, capital MT squared. That's dimension of surface tension, which is Y, is a surface tension. Look at its what? Dimension. By, then that's the full stop. They said, by dimensional analysis, obtain the values of the indices X, Y, Z, and the relationship for T. That means 2 questions in 1. First of all, they say we should get what? We should obtain the value of what? X, Y, Z, which is this and this and this. Then we should get the relationship of T to these values. When I say solution, our solution, we say T, which they say is a period, equals to K, which they say is a constant, R raised to the power X, density raised to the power Y, and the surface tension raised to the power Z. And I remember that what? The unit of R, which we call radius. Look at it, they say R is the radius of what? The drop. R is the radius of the drop. And we say that radius is same thing as a distance. And distance is same thing as length. And what's the unit of radius? Meter. Have you seen? I have removed the radius and put its unit, which is what? Meter. Then here they told me that this man is a what? Density. And what is density? Density is mass over volume. Have you seen what I put here? Mass over volume. Density is mass over volume. I have removed the density and put mass over volume. And all raised to power Y. Look at it. This Y is still raised to power Y. But I have removed the density, the symbol for density, and put mass over volume. Then I now come here. What did they told me? They told me the dimension of this surface tension is this. Look at the dimension of surface tension and look at the surface tension, which is Y. I have to remove it and put its what? Dimension, which is capital MT squared. And all will be raised to power Z. You remember? All will be raised to power Z. As I've removed this Y and put what? MT squared, which is dimension, all will be raised to power Z. You remember? Just like the density, I have removed Q and put what? The mass over volume, all will be raised to power Y. Are you there? Now, I have removed R and put meter, which is the unit, all will be raised to power X. Then equals to, what's the dimension of meter? What's the dimension of length? Is capital L. That is the dimension of length, capital L. Fundamental dimension of length is capital L. I have removed meter and put what? Capital L. You remember that we'll get a dimension of any value, any drive unit or any drive unit will get his what? Dimension from his what? Unit. I can't get a dimension without getting the unit of that quantity first. So you first of all get the unit of the quantity before you can get its dimension. We now see that from unit I get dimension. So the unit of what radius is meter, and the what dimension of the meter, which is the length, is capital L, and the unit of mass, look at it here, is the mass. Unit of mass is a what? Kilogram, and the what unit of volume is what? Meter cube. Have you seen it? The unit of mass here is kilogram, and the unit of what? Volume is what? Meter cube, and all raised to power y. Then here I take this dimension, it's already giving me dimension, I put it there, z. Then come over here, z is equals to L, which is the dimension. Then what is what? The dimension of mass. The dimension of mass is capital M. The dimension of kilogram, which is mass, is capital M. And the dimension of what? Meter cube. What is the dimension of meter? Is capital L. And it will be what? Cube. And that's what you see here. Capital L for meter, and the raised to power what? 3, which is what? Cube. And this one become what? The dimension for what? Mass, which is what? Kilogram. And the dimension of kilogram is capital M. Then mt squared is the dimension of surface tension, which is already given to us, and can be raised to power z. Then I come over here. You remember that this man now is this, and this, I can write this m, capital M over LT raised to L raised to power 3 as this. I can write it this way. You remember? How did I do that? Somebody will say, how? We have treated this before. You remember that indices told me that what? 1 over A is equals to what? A raised to power minus what? 1. Therefore, if I have M over L squared is same thing as M into what? 1 over L cube, I mean to say, and that will give me what? That will give me M into what? L raised to power minus 3, which will give me what? M raised to power minus 3. I think you get it right. So this is same thing as this. Therefore, this man, which is M all over L raised to power 3, is same thing as what? M, capital M into what? 1 all over what? L raised to power what? 3. And this is same thing as what? Capital M times what? L raised to power minus 3. Because indices have told us that what? A raised to power what? 1 over A raised to power N is same thing as A raised to power minus what? N. So that's what we see here. Then I come back here. I think you have understood how we get this here. Then now coming over here, I have to open the bracket. What happened? I have to open bracket, open this bracket, open this bracket. When I open this bracket, I'll have L raised to power X. And when I open this bracket, I'll have y times what? The power of y times the power of m, which is 1, will give me y. Have you seen it here? And the power of this y times the power of what? L raised to power minus 3, it will give me what? Minus 3 times what? Y. Are you get what I'm saying now? You remember what indices told us? Indices told us that if I have what? Look at here, indices told me if I have A raised to power what? M, and y and the b raised to power what? N, all raised to power y. If I open this bracket, it will be A raised to power m times what? Y, and what? B raised to power n times what? Y. And that's what happened here. If I open this bracket, this L is already raised to power 1. 1 times x will give me what? L raised to power x. And here I have two things here, m raised to power 1 and L raised to power minus 3. If I open this bracket, this y will times m raised to power 1 here will give me what? M raised to power y, because y times 1 times anything is that thing. Then now, L raised to power minus 3 times y will give me minus 3y. Have you seen it's minus 3y? I have finished with this bracket. I come to this one. The same thing I did here is what I'm going to do here. This z is a power. Then this m here, capital M is raised to power 1. And this will be what? Capital M raised to power 1 times what? Z. That's the 1 times z will give me what? Capital M raised to power z. Then here, t raised to power 2. 2 times z will give me what? 2z. Have you seen it now? So this man will times every power on these people. If I open this bracket, look at what I mean. If I open this bracket now, this power will times the power of z. power of t, which give me 2z. This power will times the power of m, which is 1. Power of m here is 1. 1 times z will give me what? M raised to power z. And this will give me what? T raised to power 2z. The same thing is applicable here. This power will times the power of L, which give me minus 3y. Then the power, this power will times the power of m here, which is 1. 1 times y will give me what? M raised to power y. And that's what we have here. Then now, I will begin to collect like terms. Watch me here. I will begin to collect like terms. This man is raised to power L raised to power x, and here L raised to power minus 3y. They are the same thing. I get what I'm saying now. They are the same thing, and all of these people here are multiplying themselves, you know. These things here, all of them are what? Jamming themselves. They are multiplying themselves. So any of them can be in any place. Can you come over here so that you understand what I mean here? Can I clean here so that we can understand what we are talking about here? Well, look at it. I say that what? A, B, C is the same thing as what? B, A, C. You know that this thing can be rearranged this way. And this thing you see here is the same thing as A times what? B times what? C. And the same thing as what? B times A times what? C. Do you know that? And that means that 3 times what? 2 times what? 1 is the same thing as what? 2 times what? 1 times what? 3. And it will give me the same thing. So, and I have this. That means indices also told me that what? A raised to power what? N times what? A raised to power M is same thing as what? A raised to power N plus what? M. What do you say? A raised to power what? N plus what? M. And this man here is constant. You remember that this man, this plus is constant. Why this man is a variable? Then in this case now, we have what? I have L raised to power x, which is also dancing what? L raised to power minus 3y. I will have this to be what? L, they are of the same base. Look at it, they are of the same base, and they are multiplying themselves. You remember, the indices rule tells us that what? A raised to power n times what? A raised to power m can be written as A raised to power n plus what? M. And I told you that this plus is constant. Then that means that if they are of the same base and they are multiplying themselves, that I should add their power. What does it mean? If they are of the same base and they are multiplying themselves, I should add their power. That means these two conditions must satisfy. They must be of the same base and they must what? Multiply themselves before I can do this. Then coming to this, and I see that this K is dancing L, L is dancing M, M is dancing L, L is dancing M, M is dancing T. So all of these people are dancing themselves. So I can take any of them close to each other. I can take this man to dance this man, which is of the same base. I can take M to dance M, which is of the same base. I can take this T, which doesn't have anybody to dance each other to have the same base. So this man and this man is of the same base. This man and this man is of the same base. That's capital M and capital M here. He's of the same base and they are dancing themselves. This man and this man is of the same base and they are dancing themselves. Therefore, I can write this. L raised to power x times L raised to power minus 3 can be written as what? X plus what? This minus what? Y. What do we say? Add their power. This thing here is same thing as this. Then the last things I will have what? L raised to power x minus what? 3y. Then that's what we are trying to see here. And I come here to say what? This man, and this man are dancing themselves when I have L x raised to power minus 3y. That's what I process. Are you understand that? Coming to this man here, this and this are dancing themselves and they are of the same base. I will add their power. What did I do here? M y plus what? Z. And this man, L raised to power minus 3y and L raised to power x, they are dancing themselves. Therefore, I will add their power. And I told you, adding their power here, watch over again. Adding their power, what does it mean? Look at it here. Adding the power now, I have L raised to power x plus. This plus is constant as I told you. And this man will be minus what? 3y. And you see that what? Plus times minus will give me what? Minus. Plus times minus will give me minus. I will have L raised to power x minus what? 3y. And that's how we get this. I get what I'm saying? Then coming to this man, I come to what? Capital M. Capital M raised to the power y and capital M raised to the power z are of the same base and they are cancelling themselves. Therefore, I will have to add their power. Become capital M raised to the power y plus z. Then this z raised to the power 2z, this t, I mean to say, this t raised to the power 2z doesn't have anybody in like term. So I have to leave it to t raised to the power 2z. Then now, this thing is something as this, being that t is equal to k times what? L raised to the power x minus 2y. Nobody is confused, I will get that. That capital M raised to the power y plus z, nobody is confused about that. And t raised to the power 2z, nobody is confused about that. We now come over here. What does indices equation say? We remember that indices equation tell us that what? If we can make the two bases of the equation to have the same base, automatically their power is equal. What does indices equation tell us? Indices equation told us that if we can make the base of two sides of the what equation, indices equation, to be the same, automatically their power must be what? The same. Look at it. If I have this now, if I have what? If I have 2 raised to the power x and is equals to what? 2 raised to 8. If I say this man is 2 raised to the power x is equals to what? 8. This is the what? Indices equation. And if I can make these two sides to have the same base, automatically their power is equal. That's what the indices equation told us. That if I can make the base of this side and base of this side to be the same, automatically their power is equal. I will now say that this is what? X raised to the power this and is equal to what? 2 raised to the power 3 will still give me 8. Have I changed anything? No. 2 raised to the power 3 will give me 8. What does it mean? 3 times 2 times 2 times 2 will give me what? 8. Therefore, I have made the base 2 here, base 2 here. Automatically, I can now say that x is equal to what? 3. Are you saying? I have made the two sides to have the same base. Automatically, x is equal to what? 3. That's what indices equation told me. If I can make the base of the two sides of the equation to have the same base, automatically their power is equal. That's why I have made this 8 to be what? 2 raised to the power 3, which is the same thing as 8. I have 2 base here, 2 base here. That means x is equal to 3. As nobody is confused about this now, then since we know this is this equation, I come over here. This is the same thing as what we did there. What's happening here? This is indices equation. Look at this equation, this side. Look at this comparison here. I can make this side and this side to have the same base. If I make this side and this side to have the same base, automatically their power must be equal. You know what we said? This equation says if we can make the both sides of the equation to have the same base, automatically their power is equal. And this is indices equation. Then what happens? This might have what base? L here, base M, base T, and base K. You remember that K is a constant. We don't deal with a constant. Constant remain constant. When we are talking about dimension, constant is a dimensionless. Therefore, this K, we are regarding it because it's a constant. So what's the base? This is base L, base M, and base T here. Then what did I have here? Base T only. So what will I do? I have to make these two sides to have the same base. I call L. That's what is missing here. L, M is missing here. Bring L. L raised to the power 0, which is 1. And 1 times anything is that thing. M raised to the power 0, which is 1. And 1 times anything is that thing. And I have L raised to the power 0, M raised to the power 0, and T raised to the power 1. This thing you see here is same thing as what? T raised to the power 1, which is T here. Because L raised to the power 0 is 1, and M raised to the power 0 is 1. Why am I doing this? To make them to have the same base. But watch now, they have the same base. The base I see here is L, and the base I see here is M, and the base I see here is T. What did I see here? Base L. What did I see here? Base M. What did I see here? Base what? T. But I didn't change anything because what? L raised to the power 0 is 1, and M raised to the power 0 is 1, because anything raised to the power 0 is 1. And 1 times anything will still give me this back. Then I have made them to have the same base. And this K, you remember they told us, come over here, they told us where what K is a what? Constant. Constant means what? Ordinary value, so it doesn't have any dimension. When we write 2, if I write 2, 2 is a constant, it doesn't have a dimension. So what that have a dimension is a what? Not a constant, it's a variable. Then I like say this and this are now the same what? Base. Therefore I can now say what? Their power is what? Equal. If the base are the same, the power will what? Equal. I can now begin to equate their power. This is L raised to the power 0. That means 3x minus 3y is equals to 0. And again, y plus z is equals to 0. And what? 2z is equals to 1. Because anything you write is raised to power 1. That's t. This t you see here is raised to power 1. That's why I said t here raised to power 1. And I said this implies, what does it mean? This implies 2z, look at this 2z, is equals to what? 1. So when I say 2z is equals to 1, therefore z is equals to 1 over 2. That's settled for z. I've gotten z. And I come back here and I say what? That y plus z, look at this, y plus z, are you watching here? Y plus z is equals to 0. Have you seen it now? Y plus z is equals to 0. But I have known my z. I know my z to be 1 over 2. And I put my z 1 over 2, making y subject of formula, and I see that y is equals to minus 1 over 2. I have gotten my z and y. Then I now come back here to say what? X minus 3y is equals to what? Z is equal to 0. Look at it. X minus 3y is equals to 0. Equating the power. I'm equating the power of each of them. Then I will now say x minus 3y is equals to 0. Therefore, I know my y to be what? Y minus 1 over 2. And I put it over here. Minus 1 over 2, which is this y. Close the bracket. And I now say minus times minus will give me plus. I've been saying minus here times minus will give me plus. And this 3, which is over 1 times what? 1 will give me 3 over 2. You remember that if we write 3 like this into what? 1 over 2 is same thing as what? 3 over 1 times what? Times what? 1 over 2, which give me what? 3 over what? 2. 3 times 1, 3. 1 times 2 will give me this. That's what we see for this now here. Then from here, making my x object of formula, when I say this man coming over here become what? Minus 3 over 2. And I have gotten my what? X. That's the value of my y is already gotten. My value of x is already gotten. And the value of z is already gotten. And that's what we say by dimensional, obtain the value of what? The indices x, y, z. And that's what we have gotten here. Therefore, the value of x is equals to minus 3 over 2. The value of y is equals to minus 1 over 2, and the value of z is 1 over 2. That is our answer. Then I come here and say relationship for t. Relationship for t. That's the second question they ask us. We should get the relationship that connect this t to this people. When I come into look at t, we are going to take this value to substitute into the equation that they give us. Look at the equation they gave us. Now we are taking the value of y, z, and x to put in that equation. When we put it, I have that this x turned to be minus 3 over 2, and the y turned to be minus 1 over 2, and z come to what? 1 over 2. Then you remember that this man is a constant, is a dimensionless. When we say constant, it means what? Dimensionless. I have to bring them out. And what will happen? This thing now you see here, this, we know that indices told us that when we have minus what? N over m, that this is something as 1 all over a raised to power n over m. And this is something as what? This is something as what? 1 all over what? The m cube root, or the root of m, a raised to all raised to power what? N. This is what indices told us. That I can write this 1 all over what? A raised to power n over m n over m as 1 all over the m must stand for any value, which is if it turn to be 3, it become what? Cube root. So I have what? M here and a all raised to power what? N. That's what indices told me, that I can write this way, and I can write this way, or this way. So now, going over what we have done now, I have that this man now is this. So this now I write here can be written, that implies, can you watch here? Can you watch here now? Let me clean this list so that we can see. That means that this man here, r raised to power minus 3 over 2, can be written as 1 all over r raised to power 3 over what? 2. And it can be written as 1 all over the roots. This root stands for 2, this root stands for what? 2, and it will be what? Root 3, root x all raised to power what? 3. And that's what you see here. Look at it now. That's what you see here. I have written this man this way. And look at it over here. Then the same thing happened here. This density raised to power minus 1 over 2 can be written as then 1 all over what? Density raised to power 1 over 2. Have you seen it? And this y remain as it is. Look at it now. I have 1 come over here. I have 1 all over what? Density raised to power 1 over 2. And here I have 1 all over r raised to power what? 3 over 2 times y raised to power 1 over 2. And you remember again, as we said again, that indices told me, you remember again that indices told me that if I have 1 all over a raised to power n over m, that I can write it as what? 1 all over the root, which you call m, of what? A all raised to power what? N. And that's, if this is what indices told me, therefore I can write 1 all over r raised to power 3 over 2 as what? 1 all over roots of what? R all raised to power what? 3. If I'm applying this what? This law, I will have that this man like this can be written this way. And also, I will not have that this, look at here, this have turned to be this. I think you have seen what I'm talking about. Then this man will now be what? Written this way. The same thing. Are you going to say that? This, the density raised to power 1 over 2 will be written this way. And this man will be written this way. You remember, how did I get that? I'm still doing the same thing I did in indices. We said that what? That this 1 over what? Density raised to power 1 over 2 can be written as 1 all over root of what? Density. And also, if I have root A, this root A imply what? A raised to power 1 over 2. Are you getting what I'm saying? If I write root what? Y, root y is same thing as y raised to power 1 over 2. Therefore, this y raised to power 1 over 2 can be written as root y. Have you seen it now? That this man now, this can be written as this. Then you will now close the bracket. Then I continue. I can now see that this is over 1. You remember that this man now is over 1. And this times 1 will give me y. And this times this will give me this. Isn't it? Are you getting what I'm saying? This times this will give me this. And this times this will give me this. And that's what you see here. I think you're following me now. I have y raised to power root y over root q. Then this is a root, which is common root. It can be written this way because this is root, this is root. Then I have a common root for 2 of them. And I have y over what? The density, which is common root. This becomes 1 over this times this, and the k outside. And this can be written k times 1, because this k you see here is over 1. And when I say k times 1 and 1 times this, that will give me k over what? Root r, all raised to power 3, all common root of y over density. And that becomes what? My answer. And that's the relationship between what? T relates to this. That means we are talking about t is equals to this. So we can write this t as this way. Are you getting what I'm saying? And that's the relationship they told me I should get the relationship for t. And that's my what? Answer.